right? So in today's class, we are going to study how to check whether a decomposition of a relation is going to be lossy or lossless decomposition, right? To identify whether a decomposition is a lossy or lossless decomposition, it must satisfy the following conditions. So we have three conditions to check whether a decomposition is a lossy decomposition or lossless decomposition. So the first point is like the union of the fragmented relations should give you back the original relation, right? So whenever you are going to decompose a relation or into fragmented relations R1 and R2, the union of the fragmented relations R1 union R2 gives you back the original relation capital R. We say that the decomposition is going to be a right. So the first condition is that the union of the fragmented relations should give you back the original relation. The second condition is that R1 intersection R2 should not be null value, right? So whenever you go for a decomposition of relations, decomposition of a relation into fragmented relation, the intersection of the fragmented relation should not be a null value. And finally, R1 intersection R2 logically determines R1, or R1 intersection R2 logically determines R2, right? So the intersection of the fragmented relation should logically determine any one of the relation, right? So these are the three conditions to check whether a decomposition is a lossy decomposition or lossless decomposition, right? So let us look into the example one, right? So in example one, let us assume that you have a relation R with attributes A, B, and C respectively. So you are going to decompose the relation R into fragmented relations with attributes with relation R1 with attributes A, B, and R2 with attributes B, C, and there exists some functional dependency between the attributes in a relation, right? So the valid functional dependencies that exists in the relation are like A determines B, A determines C. Now you need to check whether the decomposition is a lossy decomposition or lossless decomposition, right? Right. So we'll check for the three conditions, right? So D is equal to the relation R contains the attributes A, B, C. You are going to have your fragmented relations R1 with AB and R2 with BC, right? So the union of the fragmented relations R1 union R2 gives you back the original relation capital R, right? So R1 union R2, AB union BC, it gives you back the original relation capital R, right? Hence the decomposition, right? Hence the first condition of the decomposition is met. Lossless decomposition is met. Like we'll look for the second condition. The second condition states that R1 intersection R2 should not be null, right? So again, we'll check for the second condition, AB intersection BC, right? So it's going to be a B, right? So AB intersection BC, it's not null, and it gives the result capital B. So again, the second condition is met for lossless decomposition. Now we are going to check the third condition, right? So the third condition is that R1 intersection R2 logically determines R1, or R1 intersection R2 logically determines R2, right? Now we are going to check B closure, right? So R1 intersection R2, the solution is going to be B. So you need to check whether B closure logically determines AB or B closure logically determines BC. So what is B closure? So B closure is going to be only B, right? So last class we studied this closure property, right? Whereby you will be able to identify all the other elements determined by an element. So here B closure is going to be only B. So B cannot determine either AB, or B cannot determine BC, right? So we say that it's going to be a decomposition is a lossy decomposition, right? So hope you can follow this, right? So we have three conditions for decomposition, right? So whenever you are going to decompose a relation R into a set of fragmented relations R1, R2 till Rn, right? So the conditions you need to check for lossy or lossless decomposition is that the union of all the fragmented relations should give you back the original relation. So R1 union R2 is equal to R. The intersection of the fragmented relation should be not null, right? R1 intersection R2 is going to be not null. And the last condition is that R1 intersection R2 logically determines R1, or R1 intersection R2 logically determines R2, right? So if these three conditions are met, we say that the decomposition is going to be a lossless joint decomposition, right? So in example one, first two conditions were satisfied, right? Whereas the third condition is not met in the example one, and we say that it's going to be a lossy joint, right? So we say that the decomposition is a lossy decomposition, right? So now I think you can right. The thing is that you can have a piece of paper and pen, and you can work on this problem. So the second problem is like you have a relation R with attributes A, B, C, D, E, F, right? So you have totally 6 attributes in the relation R, right? So we are going to decompose the relation R into 3 fragments: R1 with attributes A, B, R2 with attributes B, C, D, and R3 with attributes D, E, F. And there exists some functional dependency between the participating attributes, right? So the valid functional dependencies that exist in this relation are A determines B, B determines C, C determines D, and E determines F. And we need to check whether the decomposition of relation R into R1, R2, R3 is a lossy decomposition, or it's a lossless decomposition, right? So I want you to work out and get me the result.
Sir, but isn't the intersection null? The second condition fails, no, sir, in this problem.
So second condition fails, huh?
Yes, sir,
No,
because
sir,
we have
one is satisfied
A, B
because
in one. The intersection would be for R1 and R2, the intersection would be B, and then you don't have any B in R3, so the whole intersection would be null.
Sir, but shouldn't we actually be checking the intersect to see if at least one column is one attribute is common between any two relations? So like B is common between R1 and R2, and D is common between R2 and R3. Or do we check the total intersection?
Right, we'll start with R1 and R2 first. So R1 and R2 first, let us look for the first step. The union of the fragmented relations gives you back the original relation, right? So the first condition is met. Second condition, R1, we'll start with R1 and R2 alone. So R1 union, R1 intersection R2 is going to be
it's
B.
going to be B, but its closure will be BCD.
So B closure is going to be
BCD.
right. Then we need to check with the relation R3. Next, you need to check whether R2 intersection R3, right, is going to be valid. So R2 intersection R3, what is going to be R2 intersection R3?
D.
D, right?
Just D.
Yeah, D closure is going to be
D itself.
D.
right. Then what do you conclude?
So it's lossy.
Right. So that's it. Right. So the condition 1 is satisfied, right? The union of the fragmented relations gives you back the original relation R. Second condition is satisfied for relations R1 and R2, right? Right. So AB intersection BCD is equal to B. So B closure is going to be BCD, right? So you have your relation R1, 2, right? So you are going to combine relations R1 and R2, and you have a new relation R1, 2. So ABCD intersection DEF. So again, here the intersection value is going to be D, right? The intersection of R1 to intersection R3 is going to be D. D closure is going to be only D, and it's not a super key of either R12 or R3, and hence we say that the decomposition is a lossy decomposition, right? So we'll move on to example 3. Example 3, I want you to solve subdivision 2 and 3, right? So you can note down example 3, subdivision 2 and 3. We'll try to solve subdivision 2 and 3, right? So you have your relation R with attributes A, B, C, D, E, F, G, H, I, J. In subdivision 2, it is decomposed into 3 fragments: R1 with attributes A, B, C, D, E, R2 with attributes B, F, G, H, and R3 with attributes D, I, J, right? So you can try to solve subdivision 2 and 3 and update me whether the decomposition is a lossy decomposition or it's a lossless decomposition, right? So one of you can come forward, solve it and post it, right? Right. So we have some marks for class participation, or what you can say. Yeah, we will promote students who have contributed something for class participation, right? So I want someone to come forward and solve the second subdivision.
Sir, I'll go. Can I just say?
Saloni, I think this time let me give it to someone, some new
Yes,
student,
sir.
right? Right. So I want someone to come forward. Samuel. Samuel. Tisha. Hemant. Hemant.
Yes, sir.
So can you solve the subdivision 2 and get us the answer?
Yes, sir. I'm doing it. I'll post it, sir.
Right. Right. So others also can work on it. Hemant, what about the first condition?
Yes, sir. First condition is satisfied, sir.
Right. Yes.
And R1 intersection R2 is also a super key of R2 basically.
So R1 intersection R2 is going to be
B.
B.
And the B closure is BFGH.
Yeah, B closure is B determines F, F determines GH. So B
Yes.
closure is going to be BFGH. So the second
Super
condition is
R2.
satisfied. Right.
Yes.
Now you can integrate relations R1 and R2, right? So R12 will be A, B, C, D, F, G, H. R12
Yes.
intersection R3 is going to be
D.
yes. So R12 intersection R3 is going to be D.
Yes.
And what about D closure?
D closure is DIJ.
So it is again the super key of
R3.
R3.
Yes.
So the decomposition is so
It's lossless.
right. So it's a lossless
Yes.
decomposition. Right. Correct, Hemant. Thank you.
Yes.
So let me show you the solution for second problem. Right, as Hemant has given the solution, the union of the fragmented relations gives you back the original relation. And the second condition is going to be A, B, C, D, E intersection B, F, G, H. It's going to be B. B closure is going to be A, B, F, G, H, which is a super key of relation R2. Right, now you are going to have both the relations together, A, B, C, D, E, F, G, H. R12 intersection R2, it's going to be R12 intersection R3 Dij, it's going to be D. D closure is going to be again Dij, which is a super key of R3. Hence the decomposition is a lossless decomposition. Right, now I want one of you to work on the subdivision 3. Right, subdivision 3, we have again you have 5 fragments. Right, so totally we have 10 attributes A, B, C, D, E, F, G, H, I, J. So in this case, the third subdivision, we have 5 fragments. Relation R is decomposed into fragments R1, R2, R3, R4, R5 respectively. And again, you need to check whether the decomposition is a lossy decomposition or a lossless decomposition. Right. So again, someone can come forward to work with third subdivision. Kiran Reddy, you want to contribute?
Sir, can you show the conditions at the top, sir? Once again.
Yeah. So these are the 3 conditions. Whenever you perform a decomposition, you need to check for 3 conditions. So the 3 conditions are like union of the fragmented relations should give you back the original relation. Right. So the intersection should be not null. And the intersection of the fragmented relations, they logically determine either R1 or R2, right? R1 intersection R2 logically determines R1, or R1 intersection R2 logically determines R2. Either it determines R1 or R2. So question 3. Sneha,
So the third one is coming lossy decomposition.
it's a lossy.
So first condition is satisfied, and then second condition.
First condition is satisfied, right? So the union of the fragmented relations gives you back the original relation. A, B, C, D, union D, E, union B, F, union F, G, H. Yeah, the union of the fragmented relations gives you back the original relation.
Original.
And what about the second condition?
Second condition, if we do R1 intersection R2, it will be D, and then the closure of D plus, that is, it will be Dij.
Right.
And it is not a super key of R1, R2, so lossy.
It is a super key. R5.
R
R5 is Dij.
Correct. Saloni, right?
Okay.
Yes, sir.
Yeah, Saloni is correct. So union of the, so first condition is correct, right? So union of the fragmented, sorry, I think that, so union of the fragmented relations gives you back the original relation. So condition 1 is satisfied. So condition 2 is like D, A, B, C, D intersection D, E, which gives you D, right? And what is D closure? So D closure gives you one of the fragmented relation, Dij. So it's going to be a, it meets the requirement, right? So we are going to combine R1 and R2, right? Now R1 or R12 will be A, B, C, D, E, and we'll move on, right? So A, B, C, D, E. Now R12 intersection R2, D, E, right? So R12 intersection
R3.
R2, yeah, R3. In this case, it's we have done it R2, so it's R3. So which is going to be B, F. So intersection, it gives you the value B. So again, B closure is going to be
BFGH.
right. So B can logically determine F. F can determine GH. So it's going to be BF
Be lossless. Yeah.
or BFGH. So it's going to be it gives you R3 or it, right. So you are going to go for the next step, right? So it's a super key of R3. So you are going to now integrate A, B, C, D, E, F, right? So R1, R2, R3 put together A, B, C, D, E, F intersection R4, right? R4 is going to be FGH. Again, you get intersection value is going to be F. F closure is going to be
FGH.
right. F determines F determines GH. So FGH is a super key of R4. So again, what we do is that yeah, we'll continue. We'll say that we'll integrate R1 to R4. R14 is going to be A, B, C, D, E, F, GH intersection Dij. Now you get D is a intersection value between R14 and R4. R14 and R5, right? R14 intersection R5 is going to be R1,
The actual relation.
right? R1, 2, 3, 4 intersection 5 is going to be D. D closure is going to be D, and D determines Ij. So it determines the relation R5. So we say that the decomposition is a lossless decomposition, right?
Sir, but how is Dij a super key of DE in step 2?
So it's a super key of
R2 is DE, no, sir?
R5, it should. Super
yeah,
key of.
super key of R5.
Then we have to combine R1 and R5 at the second step, right?
Yeah. So it's a super key of R5. So D closure determines Dij. It's a super key of R5. So we are going to combine it.
So he's saying, shouldn't we combine R15 instead of R12 in step 2?
Yes, sir. It should be R15 and in brackets A, B, C, D, I, J.
Right. Subramaniam, can you try that option? That option, let us look into that option, right?
Okay, sir. 1 minute, sir. I'll do.
So can you scroll up to the relations in the question?
Question, huh?
Yeah.
So you have your relation A, B, C, D, E, F, G, H, which is decomposed into 5 fragments. A, B, C, D. You have 5 fragments, and you need to check whether it's a lossy decomposition or lossless decomposition.
Sir, in that case, it turns out to be lossy. Because after you have A, B, C, D, and then I, J, the only intersection amongst all 3 relations like R2, R3, and R4 is only D. And if you take closure of D, it should be Dij, and again, you don't have any Dij component in the rest of the relations. So it won't be a super key of the remaining relations.
Right. So this is how, I think you can follow my solution, right? So this is how I have been using it for a quite longer time. So can someone check it out? Maybe Subramaniam,
Yes, sir.
Saloni, you can check it out and get
Yes, sir. We'll present it in next class.
Right. So you can check it out and get us the correct solution. Right.
Sure, sure. So can you go to the question once again? I'll just copy it again.
Right.
Maybe. Yes, sir. Thank you, sir.
Right. So you can note down the dependency also. Right. Now maybe I have 1 or 2 problems like for tutorial or something, or we'll discuss in the next class, right? So we have some sample questions that will take in the next class, right?